Good afternoon, everyone, and thanks for attending our panel discussion on the future of scandium as a technology metal. So far dominated by China and Russia, scandium is bound to take off in other parts of the developed world too, including Canada. Why is now a good time for investors to be looking at it? This is the purpose of today's discussion, and we are delighted to have a panel of industry experts to help us sort this one out. Joining us today are Peter Cashin, founder, president, and CEO of Imperial Mining Group, Don Bubar, chairman of Imperial Mining, president and CEO of Avalon Advanced Materials, John Kaiser, analyst, writer, and owner of Kaiser Research Online, and Gianni Kovacevic, analyst, author, and keynote speaker. Gentlemen, thank you for being here today, and let's get started. This question is for you, Don. Out of all the technology metals, scandium is probably the least known. Why is that?
Well, there's not much history of production in the Western world, as you alluded to at the start. It's been just a minor byproduct element produced out of a couple of operations in China and Russia. But its time has come, obviously, because of new technologies creating more demand for elements like scandium, to start to look at creating new sources of supply. And we have them. We just have to develop the appropriate technologies to recover scandium efficiently. And that's really where the challenge is. In nature, scandium is rarely concentrated. It's a common element found throughout the world in the Earth's crust, but rarely concentrated at the levels that we're used to seeing in metallic mineral deposits of more familiar metals. So the challenge is finding resources that are amenable to recovery of the scandium efficiently and economically. And it looks like we might have one at Crater Lake.
Gianni, do you have any other comments, or Peter?
No, it's, I mean, there are significant sources of scandium in the world outside of China and Russia that I think will allow for the development of a diversified supply chain for the Western world.
Okay, thank you. Our next question, this is for Peter or Gianni. What makes scandium so special? Should the world be upset that primary scalable scandium supply at a stable price is not a current reality?
Well, certainly it's not currently available in amounts where it would be commercially viable. And that's really been the reason why scandium has not developed any somewhat of a profile. The technologies and the science behind the benefits that scandium provides, particularly as an alloy agent to aluminum, are well understood, and they've been understood since the 1970s. But ultimately, it was the lack of supply that impeded really the expansion of its use on an industrial scale. And it was first actually developed by the Russians as an alloy agent to aluminum in the building of the next generation big fighter jets. In that it was a competing material to titanium alloys, which the US military preferred. But it had additional benefits in that it was lighter weight, it was actually flexible, it provided a corrosion resistant alloy, and it had a degree of malleability or flexibility that was critically important when those fighter jets hit Mach 4, Mach 5, very high speeds. That flexibility was critically important. And it actually provided for a good weldability of the aluminum itself, which is critically important, particularly in the assembly of the various platforms that materials used for. So in terms of it, oh, Gianni, go ahead.
Well, I think for people that are just getting familiarized with why scandium is important, and it will be increasingly more important for the rest of your life. It's the low-hanging fruit in energy is to use less energy in the first place. So if we're substituting from steel to sophisticated, very strong aluminum, the secret sauce there is scandium. So if you can grow the resource globally, which I believe that's what's going to happen, especially with good deposits that are in places like Quebec, that market can grow 10 or 20x, and it will be used predominantly to have very strong aluminum, which then can substitute applications for steel. So that's what that is. Niobium is a strengthener in steel, whereas scandium makes super sophisticated, super strong aluminum. And I think there's an arbitrage of misunderstanding, which is a big opportunity for particularly retail investors, guys that follow resource stocks. This is something that I believe is going to come to a front page in the coming years. So people get acclimated now.
Thank you. The next question is for John and Gianni. What are all the applications that stand to benefit from unlimited supply of scandium?
John Kaiser.
Yes, please, John.
John, you've got your mute.
Oh. Perfect.
All right.
Yep.
The word Gianni didn't use to describe what he was saying is lightweighting. It's as we want to consume less and less energy, and we want to make everything that moves less heavy. And so you have the entire transportation sector as a candidate. They want to use aluminum, but aluminum has its limitations. And scandium is that magic ingredient, low as 0.05%. You add it in, it makes the metal, the aluminum, stronger. It also, very importantly, allows it to be weldable. And we've always talked about airplanes wanting to have aluminum scandium alloys so they can get rid of rivets, because those weld joints, because aluminum is damaged when you weld it, and then you have to do special heat treating, you can't really use welding without something like scandium in it. And scandium also bestows corrosion resistance for aluminum, which generally on above water applications is not a big deal. But when you get into the marine setting, it is a huge deal, keeping the hulls of your boats from corroding from the salt water. So that the naval sea applications is very large. Obviously in cars where you need strength more than you can get from the magnesium aluminum series that are available. And also conductivity. Aluminum is one of the most conductive elements out there, but its weakness limits its use for things that require electricity to be transferred. Most things, when you add it to aluminum, it degrades the conductivity. Scandium does not degrade aluminum's conductivity. So if you can add scandium to strengthen the aluminum without degrading the conductivity, there's all kinds of potential applications available in that regard. And of course, within the electric vehicle, aluminum is now being used in the lithium-ion battery as a separator. But the difficulty there is that aluminum, this is a harsh environment inside the lithium-ion battery. So work's being done to explore, can scandium make aluminum tougher in these more difficult environments? My own estimate is there's over a dozen different sectors that could expand to consuming 1,000 tons per year over the next 10 to 15 years, provided we get that chicken and egg problem solved of what comes first, the orders to justify spending money to develop a scandium mine, or the scandium mine supply first, so that end users become encouraged to actually deploy aluminum scandium alloys into their applications.
Great, John, thank you. Gianni, anything else to add to that?
Well, I think we're going to go through this piece by piece over the rest of the discussion. So let's
Great. Carry on.
Yep, thank you.
Perfect. Okay, what does it take for end users to commit to using aluminum scandium alloy in their product line? Peter?
To be honest with you, I think availability of supply and the security of a long-term provider of that material. Like I said earlier, the technology of the creation of the individual alloys that use scandium aluminum is well understood. What's been completely lacking is a viable, long-term, sustainable supply of material at a price point that is attractive to the various industries. With that being said, of course, in terms of the sequence of how this material and the consumption dynamic of this material will be, it's likely that the aerospace and the defense industries, because they tend to be less price sensitive on the inputs. And that's always, of course, been a bit of a impeding factor. Is the scandium oxide, as it is currently available, is very expensive. And when it to the point where manufacturers look for replacements or substitutes to a material such as scandium aluminum, and that's titanium alloys, it could be carbon composites. It's interesting that is particularly in the area of aerospace, and we're talking about long-term space travel, that as John pointed out, very small quantities of scandium are required to significantly strengthen aluminum alloys. One of the new areas of consideration for scandium use is long-term space travel. And we've come upon the statistics. It costs an aerospace company approximately $54,000 US per kilogram to get that platform into space. And even if you knock off 10 or 20 kilograms of weight off that payload, you're already in the $1 million of savings, multiplied by the number of potentially tons of weight that you can save as a result of using scandium aluminum. So I think all combined, it's a very attractive material. R&D is being undertaken almost on a daily basis with new applications, new consumption areas, and it's just now to get production capacity of scandium worldwide on the move.
Great, thank you, Peter. Don, anything to add to that?
I was going to ask a question to John. You talked about how it's can be used in lithium-ion batteries. Another one of the applications is talked about in the future is solid oxide fuel cells, where scandium can substitute for yttria and yttria stabilized zirconia beneficially in that technology. Do you see that as a big growth area for scandium demand as well, John?
Yeah, that's a more ceramic usage as opposed to aluminum scandium alloy. And what the reason Bloom Energy's solid oxide fuel cells work is because by doping the electrolyte, the ceramic electrolyte is based on zirconium and yttrium, they can lower the temperature of the system and allow it to operate a lot longer. The headache with solid oxide fuel cells is that they degrade so quickly, and that's also limited to the lithium-ion battery. You know, Elon Musk wants a million mile battery, and so scandium's a really sort of special element. And the interesting thing is now that it's becoming probable that we will see supply grow, we will see Rio Tinto is able to do some gradualist supply from its Tracy Sorel titanium slag upgrading operation. We may be getting some supply from copper oxide leaching operations in the United States that gradually build up the supply so that the end users can start using it. We have already multiple projects in Australia, laterite deposits that have undergone definitive feasibility studies. One of them, Ningen, already has a mining lease and is shovel ready. All you need is the money, but then you need the orders too to get the money. But this I think will really keep growing, and the scientists, as they're looking at that, they're putting more and more R&D into this because they can see, I mean, any new product takes five to 8 years to commercialize. So scandium is an exciting space because it's been something that's never been available on a primary scalable basis at a stable price. It's the price stability that everybody needs. This is not some optionality thing where it's going to go to $5,000 a kilo. We want to see it stabilize somewhere between $1,000 $2,000 a kilogram. And then you have different applications. They figure out, well, at this price, whatever it is that's available, we will be able to buy it. And applications like the lithium ion battery, that's not a lot of scandium you need to add to it, but there's an awful lot of lithium ion batteries that when the EV market goes exponential over the next decade, that itself could end up justifying a much higher price for scandium simply because the input is so incrementally small.
Great, great, John, thank you. Gianni, this is a good question for you. There's been a lot of action in recent years to promote a shift towards electric vehicles. Do you think this will prevail, and will we see further growth and wider adoption? If so, what role could scandium play in the EV adoption trajectory?
Well, I don't know if there's much debate anymore on how the world is pivoting for ground transportation to the electric vehicle and hydrogen fuel cell vehicle. That's already underway. And in the next 10 years, you look at the amount of batteries that they're going to build for these electric vehicles and for storage. There's more than a 10x move. You're going to see a big move in lithium. And the chemistry may change for the battery, the nuances between the different companies and the technology companies and chemistry companies. But lightweighting, ground transportation, that's happening, as John already commented on. That's really the low-hanging fruit. And I believe it's with scandium assisting aluminum, this is also a market that can grow 10 or 20x in the next 10 years. So which deposits are going to get developed, which ones have the easiest metallurgy, and which ones are located in places that could have some assistance. You have to have a big aluminum industry. So which jurisdiction has one of the biggest aluminum industries in the world? Quebec. They happen to have this type of deposit. So I think there's it's a symbiotic relationship. If they build it, they will come. So I'm a speculator, and I'm speculating that there will be growth in electro transportation. I don't think you have to argue that one anymore. I'm also going to speculate that there's going to be a lot of investor interest in the marriage of aluminum and scandium and the greater understanding of that. And so when you go down the food chain, there's not a lot of places to play it. So that's why I'm very interested in following this sector. And you have to do it through a lens of a company like I've done in other commodities. And over the past 7-8 years, anyone that's followed what we've done, we try to be a little bit early, a little bit ahead of the curve on these trends. And as Don Cox always says, never invest in the story on page 1. That's the efficient market. Invest in the story on page 16. That will one day be on page 1 above the fold. So I believe that when you put all that together, this relationship, aluminum, scandium, electric vehicles, electric transportation, and the growth of that input into aluminum is, I think it's going to be a pretty exciting story for the coming years. That's in my view.
Great answer, thank you. So this question could be for Don and John. If scandium demand does skyrocket as we imagine, where will the supply come from?
Well, there are actually quite a few potential supply sources in the short term. As John alluded to, there are sources of supply that could be looked at more realistically now involving reprocessing historic mine waste, where there was multiple elements in there that got mined for one of them, and elements like scandium that had no significant demand 20 years ago or longer do today, and these wastes can now be looked at as opportunities to recover these elements that were ignored years ago. And there are lots of examples of that, and it's all about coming up with more efficient extraction technologies to do that, as Rio has demonstrated with that titanium waste thing in Quebec.
John, anything to add to that?
Well, the various deposits that have been outlined in New South Wales, these laterite deposit were an unusual enrichment of scandium to 300 to 600 ppm. These were game changers. They only showed up about 20 years ago when companies were looking for nickel and platinum in these areas. And there is nowhere else in the world where these types of laterite deposits have formed. And they've been taken through definitive feasibility studies at scales that tap a fraction of what's available. in the ground. Like, for example, the Ningen mine, it's planned to produce 35 tons per annum of scandium oxide for 20 years, but its resource is 200 years. You take in Cleantech's Sunrise deposit, and it's got hundreds of years at that scale. So the supply is there already present. It's concentrated in Australia. There are deposits elsewhere. We're starting to see more igneous type deposits such as Crater Lake in Quebec and Kiviniemi in Finland that are have a different metallurgy, not the expensive acid and heat treatment that these laterites need to crack the scandium out of the ore. So it's already there. In terms of byproduct sources, you know, there's maybe these nickel cobalt operations, Cleantech's Sunrise project, which is the nickel cobalt variation. If that ever goes into production, that would have a substantial byproduct of scandium. These things are all waiting in the wings for the demand growth to begin to happen. And that chicken egg problem is that the demand growth can't happen until the end users are able to be guaranteed that they're going to have this. So we need, that's why I see this Rio Tinto thing as so important, because I think from that operation, the Lacteo iron titanium deposit, they'll be able to get up to over 50 tons of scandium oxide per annum. And right now, it's estimated there's between 15 and 25 tons of supply from various titanium dioxide waste stream processing, the Bionobo mine, Sumitomo's producing some from its Coral Bay nickel cobalt operation. So there's these whole bunch of byproduct supplies buttressed by primary supply coming on stream, helped out by this Rio Tinto Sorel Tracy situation. That's get it up over to 50 to 100 tons per year, and then the demand starts going through the roof, and then all these other projects kick in, and ones that are in locations closer to certain markets like Crater Lake and Quebec, then the interest for the push to get this going, make sure this is coming on stream, that's going to break out over the next year or so.
Thank you, John. So the next question is for Peter. Peter, IPG has a different style of scandium deposit than the laterite deposits in Australia. Why is Crater Lake scandium discovery something we should pay attention to now?
Thanks, Kathy. It's as was pointed out earlier, it's a magmatic deposit. So unlike the Australian examples, the mineralization is primary, so it's unaltered. And just the fact that it's unaltered and related to fresh bedrock would constitute our ability to use conventional metallurgical processes to recover the scandium from the rock itself. In terms of the geological environment, it appears to be related to a caldera collapse system and an alkali intrusion. So you can just imagine, if you've seen pictures of volcanic calderas and you see the center of the caldera as you push down relative to the edges of the volcano itself, that material, when it drops, it almost acts like a plunger. And the fault that's created from that downward movement basically allowed the system to tap the deeper reaches of the original magma source and bring it up close to surface around that concentric fracture that's been developed. So really, what that's allowed us to see is normally very deep reaches of the magmatic system that would not normally be exposed at surface. It's actually brought the very, very iron-rich portion of the system, which tends to be enriched in things like rare earths and scandium, right to the surface. And one thing, so normally these magmatic systems are enriched in the order of 300 ppm scandium metal. 200 is considered economic threshold. In the instance of Crater Lake, we're seeing values of scandium related to the iron silicates that host the scandium in the order of 300, 500, and we were seeing upwards of 1600 ppm scandium metals. So extremely unusually enriched, I think, to the point where even the literature research that we've undertaken never really is, there's no evidence of an equivalent, geological equivalent with those kinds of enrichments. So very exciting. And another point of interest is the fact that the Scandium horizon itself, which now we've traced for about 14 kilometers in strike length, is quite enriched in rare earths in the order of 0.6% total rare earths, all the way up to 9.5%. So that is an unusual circumstance. You don't usually see the direct affiliation of rare earths and scandium enrichment to that degree. So very exciting.
Sounds very exciting. Thank you, Peter. Anybody else have anything to add to this discussion? Perhaps Don has a point to make, given you're chairman.
Well, one of the things that always impressed me about Crater Lake from the first time I saw it was just the scandium grades it's pretty exceptional compared to what you see in most other occurrences where in alkaline rocks where scandium is known to occur, where often, you know, up to 100 ppm is considered very highly enriched, whereas at Crater Lake, we're seeing hundreds of ppm. I think as high as 400 or so in some of the samples we've seen there lately, eh, Peter?
That's correct, Don. But there's also evidence of an area that's returned up to 1600 ppm scandium, which is unusually enriched.
Yeah, maybe unprecedented, actually.
Well, this is certainly good news for IPG shareholders, of which I'm one. Thank you, guys. So my last question is, what is the investor sentiment towards scandium now? Do you see it changing in the near future? I'd like John and Gianni to have a shot at this question, please.
Gianni, you give it a shot.
Oh,
You're mute.
your mute's on.
Gianni, unmute yourself. There we
There
go.
we go.
Is that better? It
Yeah.
told me I had to do it. Well, that's what I find very interesting. And I speak with people. I do a lot of traveling. Haven't done that lately, but I did arrive to Europe about 12 days ago. And I am tapping the shoulder of certain friends. And I'm following IPG's work program this summer, as I think probably most people that are tuning in here. And as I mentioned before, there's an arbitrage where arbitrage of misunderstanding, or shall I say this politely in the English language, ignorance. They're not familiar with the role that scandium would play in the future of the energy economy. And it's always been associated with rare earth elements. And something that occurred about 3 weeks ago, was a group of Silicon Valley investors have floated or refloated the Mountain Pass mine. And it's called MP Materials, and they put it in one of these special purpose vehicles. And they're doing this so they can have a non-Chinese source of rare earth elements. And one of these well-known Silicon Valley investors actually gave his business case, a baseline where he sees this industry growing, but more importantly, the growth of rare earth elements because of its use in electronics, permanent magnet motors, and elsewhere in that future energy economy. But wait till these guys see the opportunity, and I believe this will come, where they see the opportunity in not just rare earth elements, but some of these things that were a market like scandium, which I believe, and I'm speculating that the market can grow 2,000%. It's the chicken and egg thing. If you have the supply, they will use it, and they will use it en masse, because 1/2 of 1% or 1% scandium turns it into a miracle product for so many different applications. We could spend days talking about it. So that's where I am speculating that this is going to become a very well talked about commodity. And if you could turn the clock back 15 years ago and talk about lithium, lithium has went through two boom markets already, and it's in a bear market. And I believe it's going to go through a lithium 3.0 boom market. So will there come a time in the next 3, 5, 10 years where you start to see not rare earth elements, but scandium and niobium boom markets? So I think that will come to a theater near you, as my friend Robert Friedland would say.
Great, thank you. We do have a question from one of our audience here. Philippe, would you, I think you're unmuted now.
Listen, it's just a comment pursuant to that comment that was addressed to how are we going to get investors to appreciate the scandium market. You know, when you're a CEO of a junior company or you're promoting it, people tend to say, well, yeah, you're preaching, you know, for yourself. So one of the angles might be academia, and this is just a coincidence, but my son is currently a civil engineer working on a master's thesis and going on to a PhD. And it's just a coincidence that he's working on lightweighting the structure of bridges made of aluminum. He's in Chicoutimi, right in Rio's Alcan's backyard. And I was questioning him on this. He says, well, Dad, you know, it's really important to lightweight bridges and make them stronger because it has everything to do with the load. And so he's not only working on lightweighting and making stronger bridge components, but he's also working with a group to lightweight and make stronger components for, you know, skyscrapers and public buildings. So my comment is to the effect that when academia starts promoting or validating all of these things that we're talking about, then, you know, the public will lock into this and say, if the experts, if the PhDs who don't have a whole bunch of stock options and warrants and you know, free trading shares, if they start promoting this, then and it's recuperated by the press and put out there, then maybe we've got an audience, a retail audience that's gonna pile in.
Kathy, I'd like to follow that up with a comment. Thank you, Philip. As a matter of fact, I have had multiple conversations with structural engineers who have said that if there was an ability to significantly lightweight structural components of buildings, that they'd really be able to significantly modernize a lot of the designs of these things. And as a matter of fact, one consulting engineer that I spoke with was involved with the Ferrari Museum in Dubai. And I don't know if you've seen it, but it literally looks like the hood of a Ferrari race car. And they said they had significant challenges, mostly related to load, in designing this thing. And although they were, and what they had to do is add additional structural steel components in order to support the design. And when I mentioned the potential of scandium aluminum having equivalent tensile and yield strength to steel, this engineer became extremely interested because they could do the same design at a significant weight saving and be able to recreate what they just did in Dubai. So thank you.
I'd never heard of scandium before 2010, except people mention it sometimes in the context of rare earths. And I've covered this space in the last decade, and there was a lot of hope, but this problem of how do you generate the demand, the orders to pay for building the supply, this problem, not even Robert Friedland was able to solve with the richest deposit and biggest scandium deposit in the world. And he eventually shifted to nickel cobalt with the scandium byproduct as a way of maybe solving this problem down the road. And right now, I think the market's attitude is, well, this is a hopeless problem. But that's where these things like Rio Tinto's Sorel Tracy operation, those are game changers. And the other reality is China, with this deglobalization that's going on and with the rising conflict between the United States and China, China's Achilles heel is its oil dependency. It's shifting to electric vehicle fleet. Yes, it's firing it with coal-powered energy, but its dependency on oil is deadly going future. And it's also 40% of the global aluminum market. So somewhere along the way, I think China is going to try and secure scandium to enhance all its domestic aluminum applications. That's the elephant in the room, is China getting serious about aluminum scandium. Right now, they don't have enough of it to do anything with it, so they get it out of their titanium dioxide, which they set up for Bloom Energy, but then Bloom Energy's sales didn't quite take off as expected. So they're sort of peddling in the market at $1,000 a kilo, but there's no meaningful supply available. I think we are at a cusp where the public's attitude could change, but it's this incrementally increasing the supply through groups like Rio Tinto and much more boring small-scale applications that build the demand, and they become happy and they want more. That's the key. We've always had this thing, oh, airplanes are going to overnight suddenly replace all their aircraft with aluminum scandium. Well, they have a 10-year certification cycle, and they're not even going to bother starting until they know there is abundant, reliable scandium supply. So it's boring stuff like heat exchangers, things like that, which are not sexy at all. Those are going to be what start to take on the aluminum scandium alloy supply as it becomes available. And then there'll be that big kick in as the other ones with larger applications say it's a reality. And then there'll be like almost an overnight transformation.
John, this leads us into a question from the audience. How much more production do we need to bring the price of the commodity down?
No, it's not a question of bringing the price down. Scandium is a dispersoid. That's why it works in aluminum, makes it stronger. It's an element that hates itself. So you put it in anything, it runs away from itself. It's far more abundant than lead. Lead is the opposite. Lead loves itself. That's why we have 40% lead deposits in the world and a superabundance of lead. Scandium, you're never going to get super enriched scandium just by the nature of this element, which is also what makes it play such a special role in aluminum. It ends up being kind of this matrix because it has a high melt point, so it crystallizes first within the melt, and then everything organizes itself around it. But it's because it runs away from itself that it has this special role.
Okay, great. Thank you. One last question. Which form of scandium is desirable for the aluminum scandium alloy application? You've given a couple of examples: scandium iron or scandium 203. Do you have an answer for that question?
What is that, Kathy? Can you repeat that?
Yeah, we're just first of all, what form of scandium is desirable for the aluminum scandium alloy application?
Generally, it's the introduction of Sc2O3, so the oxide.
Okay. Okay, great.
Yeah, it's really quite simple. The oxygen blows off when you melt the scandium oxide into the aluminum melt, and then it's just the scandium itself that is important in the aluminum alloy.
Terrific.
As Robert Friedling puts it, it's a spice metal. You sprinkle a little bit of it on aluminum and you end up with a material that's 300 times as strong as the original material itself.
Fantastic. Very, very unusual.
We do have more questions though. You want to wrap up?
Why don't we take one more question? Because we did say 45 minutes.
That's gonna be hard to choose because we have a couple of good ones. I think
give everybody a chance, actually.
We're kind of owe it to the audience because of the technical issues. So if our panelists are fine with that, why don't we quickly
go for it? I'm good for it.
Okay, so here you go. Is the best technology set for the conversion of scandium compounds to aluminum scandium master alloy, or is this an additional downstream processing step that requires further investigation investments? What about the industrial capacity to do this step? Does much exist outside of Russia or China?
Well, I'll take that one, Irene, and I'm sure John might or Don might have some comments. But as a general rule, it's interesting in that scandium to upgrade aluminum is basically the production of an alloy, and I think the intellectual property around creating scandium, what they call scandium master alloy, which is in the order of 2% scandium and 98% aluminum, is the base product that's used for the creation of all the other specifications of aluminum alloy. Now, I think the intellectual property surrounding the creation of master alloy, and there's a number of producers. There's some European producers of master alloy, although they don't produce it on a consistent basis in the United States. I'm very familiar with a couple of alloys groups that have created scandium aluminum master alloy. So that part of the formula, I think, is fairly well understood. Where the complexity, I think, comes is the technology and the research and development in the creation of the specific alloys themselves, where you put scandium and aluminum and maybe some magnesium in there and zirconium and all the different specifications. And usually what dictates what you add into the alloy is what the application is used for. Where's the specific alloy material is being used? Is it used as a sheet? Is it used as welding matrix? Is it used as in powder form for 3D metal printing?
Yeah, I would only add that 2% is the maximum you can jam scandium into aluminum. And end users, insofar as they need aluminum scandium alloy, want nothing to do with scandium oxide. They want the master alloy that they can then reblend to whatever specification that they require. So selling scandium oxide, there's never really going to be a market for it. It's going to be the aluminum scandium master alloy makers who hoover up all the scandium oxide that all these different producers bring onto the market. And that downstream component, it's an important part. Any future producer will need to be integrated. And this is where, of course, Rio Tinto has a great advantage because it already has Alcan downstream, and it just needs to bring back its master alloy production capacity, and then it can feed all its aluminum customers with the aluminum scandium master alloy that it creates from its Sorel Tracy facility.
Thank you. So another question. We know China is a source at this time. Why do we believe that they will not corner the market for scandium like they have done for rare earth elements? Maybe Johnny can, and Don take that on.
Well, I'll say that I'm sure they're going to try to corner the market. Whether they have all the resources domestically to allow them to do that easily remains to be seen. Maybe, John, you're aware of how much of a resource they have at Bayan Obo in the historic tailings waste there, because there's quite a bit of waste that would have scandium still in them there too, I would think, right?
Well, Bayan Obo is a giant carbonatite that's also an iron deposit, and the scandium shows up as seams within this system. They have to watch for it and segregate it and process it separately, but it is the only source for scandium that China has right now, and it's not a scalable source. These nepheline cyanide intrusions, such as what Peter has up there at Crater Lake, these types have a better chance of having a scandium in them than these carbonatites. And I would say that China, with its light rare earth surplus, it's probably not going to be a major scandium producer. I mean, it doesn't have these ultramafic nickel systems that create these laterite deposits we're seeing in Australia. It will never corner the market. It's going to be a taker of scandium. It's the complete opposite of its light rare earth advantage. And its heavy rare earth advantage, it's due to those weathered ion absorption clay deposits, not primary deposits such as Strange Lake or Norah Char.
Did they ever find scandium associated with those heavy rare earth enriched ionic clays?
It might be in there because it's background, you know, crustal abundance is 22 ppm. So, but whether it's worth recovering at that grade, that's the issue. It's you really want to get up there 200 ppm or better in a primary deposit to consider recovering it. And that's one of the earlier questions was, well, can we make it super cheap? Well, we can't, because the grade never gets high enough and the associated cost of recovering it is at a certain level. So, you know, maybe you'll eventually see $700 a kilo scandium oxide, but not within the foreseeable future.
I think that kind of leads us to the final question, and it's going to be a good question to end the panel with a little bit forward looking, but I'm sure Peter will take that on. Is it possible Imperial can be the next leader in the world with that huge enriched deposit? I love this question.
Well, you know, I'd like to think so. But certainly, from the indications ours is we will at the end of the day be able to define significant resources. And I think, as Gianni rightly pointed out, geopolitically we're extremely well aligned, being a player within the Quebec aluminum industry, and you know, the issue related to environmental sustainability is an important, a very important topic, particularly for green investors or green funds. We've got green aluminum production because those plants are powered by significant hydroelectric capacity. I know that the likes of Rio Tinto and Alcoa in Quebec are working at greening, significantly reducing their greenhouse gas emissions by changing the composition of the cathodes that they use in melting material to create aluminum metal. And so logistically, we're sited within driving range of all of those aluminum production centers. So I think we're extremely well endowed with a significant resource and very good logistics. But certainly from a infrastructure standpoint, aluminum production infrastructure standpoint, we're very well placed.
Thank you. Kathy?
Well, yeah, I just want to thank everybody for joining us. Sorry for the glitch in the beginning, but I really enjoyed hearing your answers, understanding more about Scandi, and I'm sure your audience has as well. So any further questions, please feel free to email Peter or somebody at CHF, myself. We'll be happy to answer them and join you maybe another time on a seminar like this. This has been a great discussion. Thank you so much, and thank you to our panelists. Your knowledge was beautifully shared to a really nice crowd of people. Bye for now.
Thank you.